To attend last month's event because I was at Microsoft Ignite. I know, did anybody else have a chance to go to Ignite? No? Anybody? Have you ever been to Ignite?
Yeah.
Yeah.
Not since Houston though.
I was at Houston too. That was a really good one. So Ignite is Microsoft's big event. They got rid of all their small events and they just really do the one large one now, and it's massive. Now, this one kind of sucked from the point of view of the venue. The venue was just horrible. It was two really large buildings that were about a 10-minute walk apart, and instead of having the traditional hour and a half presentations, they had all these short 20 or 30-minute presentations. So I finished one presentation, and I want to see another one. I look up the room, and it's the next building over. So it's like, well, I'm not going to make it. But they did some other cool features where they had these rooms here. Like this one room here had 12 different screens, so you can go in there, pull on your audio device, and just look at any screen you wanted to, and just listen to it on the audio. So if you weren't sure if you want to see a couple, you go there and check them out. So I saw lots of different things like keynote speaker, some Cosmos DB stuff. Being an engineering system, we have a PLM system, which is it's almost like a check-in version control for all of our different parts and things like that we build. And we replicate our database worldwide, and it's not fast enough. It's always slow. But Cosmos DB on the Azure backbone is super fast, and we've done some tests with it, and it's just amazingly fast. Don't know how much it's actually going to cost us if we switch to it. So I started going to some different meetings on that and checking that out. Went to a bunch of live recordings and a keynote session, of course, and a bunch of Azure stuff. Everything was very cloud heavy at this presentation. So that's why I was looking at doing some of this container stuff. It can be on-premise and in the cloud, and it's portable, you can move between. Some of the other cool people I just want to mention while I was there, I met Catherine Wilhelmsen. So she's a SQL Pass person. She's huge in the databases. If you're on Twitter, she's always posting a lot of good stuff there. Laura Rogers is a SharePoint. She does a lot of SharePoint stuff, especially for non-developers and has tools. She has her own consulting service, so she markets pretty heavily on the educational and training part. And Tobias, I forget his last name, he's a SQL expert. He was talking a lot about SQL Server 2017 and running SQL on Linux and all that fun stuff. And I actually got to meet Julia White, Microsoft Corporate MVP. So if you've ever watched a Microsoft presentation, she generally starts it off and talks about it first. So I got to meet her in person, which was really awesome. Talked to her for about 10 minutes, so I felt like a superstar after that. Like, so you want me to come work for Microsoft, or just let me know? So before we get started, how many people have worked with containers or are working with containers already? One. Anybody else? No? So I really wanted to do this presentation, or even after attending the Microsoft Ignite event, because for the first couple of days, I didn't know anything about containers, and I went to about 5 different presentations on containers, and I knew almost even less. The problem with all these presentations was they were really focused on developers. So they were talking about how, from the developer point of view, it was very easy to spin up and to copy and do all this stuff and send it out over to your infrastructure team on how to install it. So I would be asking people, okay, so as an infrastructure guy, how do I install containers? How do I make that container you gave me run? And they're like, well, you just put it on your Windows server. You just put it on into Docker. You just put it onto this. And I'm like, okay, but how? How do I get that to work? And then what about all this talk about how I can convert existing applications? So I have a running application on a web server. So I've got, I have 5 different websites. They all use port 80. They have different host headers, and they all run these different sites. How do I put that into a container and put it in the cloud? And nobody can answer that question. It was just kind of ridiculous. Then I went to the expo floor, and Microsoft had this big thing going on, and they had all their different experts down there. So I was talking to some of the experts. The developer experts couldn't help me at all, and I talked to one guy. He helped me out. But then I stood in line to try to win this free Xbox, like everybody tries to win free stuff. And I got to see this video, and it's going to clearly explain to you in about 3 minutes what containers are, and then I'll tell you what containers really are. So I'm going to jump over this video quickly. I think it's worth the watch because it gave me a lot more questions and just made me think, what the heck? Are you seriously? This is your container video for Microsoft?
Did you win the Xbox?
No. But I did play this video.
Lift and shift your applications with NanoMan, Connie Containers, PowerShell, and Virtual Machine. Together, these are the heroes of the cloud. We find our heroes grappling with an application run amok.
I hate it when apps give you trouble on the way to the cloud. The only thing worse would be, I don't know, fighting a giant unstoppable legacy app.
Your conjecture has yielded the worst outcome.
The app has gone into a cascading failure and will only continue to increase in size.
threat growing graver by the second, our heroes work as a team.
This looks like a job for Nano Man.
Oh, never mind.
Container, spit up additional microservices. I'll take care of this myself. What? Wait for the team? We've got to act now. Boy, I may be in a little over my head.
I've never seen a rogue app so powerful.
Our task is now twofold. Protect the path to the cloud and save our comrade, Nano Man.
Virtual machine, I need your protection while I use the scripts of Monad to fight this app.
Our shell is growing mightier.
We must prepare our defenses.
You know, you guys could loosen up a little bit. Nano Man had a sense of humor.
We're not as powerful without Nano Man. This may be our last day.
And that means no more job for me. Come back, Nano Man. Come back. Wait, Container, you have an idea? Save Nano Man by combining with him to emerge more powerful than ever? Yes, a containerized image of Nano Seven.
We'll have a smaller footprint,
Increased flexibility and portability.
and we can containerize the monster app and move it to the cloud. That's just crazy enough to work.
I'm back, and I'm smaller than ever. So this app can't keep me out. We're going in.
The scripts are working.
The shields are holding. I'm still narrating. Just as Nanoman and Container are more powerful, so is Windows Server. Modernize your apps and heroically lift and shift them to the cloud with little or no code changes. Visit aka.ms/Windows Server to learn more about the heroes of the cloud and the latest updates to Windows Server.
Okay, so that sounded awesome, didn't it? So we can just scan our apps, containerize, and move them to the cloud. You can't. There's no magic scanner. You can't just do that. It doesn't work like that. And I was sorely disappointed too. I was asking everybody, I'm like, well, just watch this video. I can just scan it. Where's the scanner app that lets me take my, old IIS application running on Windows 2003? How do I move that to the cloud? And I'm like, well, do you have the original source code? No. So I want to containerize it. Well, without the original source code, you can't redo it. You have to rebuild and redeploy. You can't just scan your app. So that was the funny video, and that was kind of the eye-opener. So it's where I met, so on the floor I met Aaron Westlake, and he talked me through it all. So I had all these questions. He was the first person who was a non-developer who could actually answer the questions for me. So we whiteboarded it up. So we're looking at, how do I take my application running a VM, and where do I get it into a container, into Docker, into whatever, and we went through a bunch of things, and he kind of showed me. So I'm going to hopefully try to explain some of those things here today. Again, I'm not an expert, it's just what I picked up, so hopefully I'm explaining everything correctly, and you'll learn something out of this today. So, we'll start with, what are containers? So containers are an abstract, isolated, and portable operating system environment. The container and its guest applications are abstracted from the underlying hardware resources and are logically isolated from other containers. So this is an example of what a container would look like. We have our application and our runtime systems, and they sit above a container management, and which sits on top of the operating system. So we'll have 3 containers in this example on top of the container manager. So containers still use virtualization, but it's a different form of virtualization. Now, containers are like virtual machines, but they don't rely on a separate hypervisor layer. They're supported by the underlying operating system. And virtual machines contain their own operating system. So that was our first example here, where it sits on the container manager, and an actual virtual machine will have its container as you were with an operating system sitting on top of a hypervisor, sitting on top of the operating system. So that's our differences there. Now, containers, they allow developers to package up their applications with all the parts they require, such as the libraries, DLLs, other dependencies, and ship it out as one package. So they can give me that container, and I can put it on my server and use it. They're supported by Linux, Microsoft Windows Server 2016, and managed by servers such as Docker, or tools such as Docker, PowerShell, Kubernetes, etc. And is there a difference between Windows containers and Linux containers? Yes. Yes, there is. So some of the differences. I am by far from Linux expert, barely even a casual Linux user, so I'm going to try to explain this the best I can. But as I understand it, there's 3 main differences. The first difference is in the system processes. So Linux exposes its kernel functional levels via syscalls, where Microsoft exposes its kernel mode via DLLs. So a little bit of difference there. The OS architecture is different. So Windows Server 2016 container implementation has a compute abstraction layer. This allows Microsoft to change lower level APIs without changing its public APIs. And that looks something like this. So we have our Windows architecture and Linux. So Windows has this abstract layer here, so they can change stuff down here without affecting the top one. Whereas in a Linux architecture, if they change it, they've got to change everything. The third difference is in the file system. So they use something called a union file system. So a union file system allows files and directories to be of separate file systems known as branches to be overlaid and forming a single coherent file system. The current implementation of Windows containers does not contain a true union file system. It instead creates new NTFS disks per container and then separates them that way. So I still find this a little confusing, and hopefully it'll clear up as I go a little further along here when I start talking about the different images and different layers. Yeah.
Well, what exactly is a container? When you're referencing a container, what exactly are we referring to as a container?
What actually is the container? So it's an isolation, it's an abstract, and we're going to get more into it. It's going to be based on an image. So a container has part of an image, and sorry, it'll explain better once I get in there. Yeah.
Would you say that a container is a VM without the OS?
I would say yes, but we're going to see it actually does have an OS. It's just not the same.
Okay. It sounds like it's not. It doesn't have a full. Like if it's a Windows container, it wouldn't have a full Windows operating system. It might be a micro.
Yeah, it's going to be like the Nano OS or a stripped down version like that. They have different versions, which I'll be able to show.
Sorry, about that union file system. I know you.
Yep.
Don't you say you didn't know much about it? Would you, from what you think it is it kind of like layering?
Yeah, it's definitely like layering, and I'll have a slide on that. It'll show the difference of your base level, and then you layer on applications on top of that in different parts that you need. So the union file systems handle it really well, and there's a bunch of different union file systems, and I have those in another slide. So that was just a quick high level of just Windows versus Linux, but we also have the difference between Windows containers versus Hyper-V containers. So this is where I was talking about how this thing got really difficult for me very quickly to understand, because at first it's just containers, and now it's like, well, there's Windows containers, there's Linux containers, there's Hyper-V containers. Which one is anybody talking about at any given time? So I'm hoping it'll all kind of wrap up close to the end and be a little bit clearer picture, or I'll make it worse for everybody. So Windows containers versus Hyper-V containers. Windows containers, they share a kernel with the host operating system, and all containers running on the host. They do not provide a hostile security boundary and should not be used to isolate untrusted code. And what we mean by that is the process is running on the host, and you can actually see that listed in Task Manager. So if I have my Windows host and I have 2 containers on it, I can see the container processes running on that host. So I could potentially have access to them from the host. Whereas when we talk about Hyper-V containers, there's a thin virtual machine on top of the host with like Nano server. Each container has its own kernel. It gives a higher level of isolation, and it's designed for multi-tenant hosting with the same security assurances as an actual virtual machine. So this would be a picture of how it looks. We have our different containers, 3 containers. They're all sharing one kernel. That's on our Windows containers. Our Hyper-V containers has a container and its kernel is separate, and it's sitting on top of the hypervisor layer. And that just kind of helps keep things secure, because they're all completely separate now, where here there is that commonality where you could actually see stuff from that kernel. Okay, we're going to talk about images and what images are. So an image is a file built from a series of layers. Each layer contains a different set of instructions. So layer 0 would be our empty base layer. Then we'd have some kind of OS, Nano server, Debian, etc. Then we'd have our applications on it, like SSD, SSHD, Perl. Then we'd have our actual applications that we're using on top of that part. So we have all these different layers, and I have visual representation in a second. The The images are like in a hierarchy, they're almost like snapshots. If you've ever looked in like VMware Manager and looked at your snapshots, you can see them kind of building out. And that's essentially what these are. We just keep dropping things on top of them, and they're all presented as one continuous file system instead of a bunch of different things that are separate. And it also allows you to share images because you effectively have a tree. So if I have one nano server image, then I can have application 1 and application 2 sharing that same base image, so I don't need to have multiple copies, whereas like a virtual machine has an OS installed each time. So anytime you want to access an application, you pull a branch of the tree like this. So we have our base, we have our Debian, we have our different applications, and then other apps on top of those. And images can also contain other images. So you could make an image that has a certain package like those installed, and another image that has those installed, and they could be overlapped on top of each other. So a container is an image with a top writable layer. So our image layer is static, it's set, and it doesn't change. Whereas our container layer has this writable top level where you write changes to. So it writes, so any adds, modifies are stored in this writable layer, such as that. So that's our layers we were talking about. So base OS, our IIS web server, something like that, application 1, application 2, and then these are the things that write on top of it to actually make it a container. So this underlying image isn't changed, but these top ones could change. And when a container is deleted, all you're actually doing is deleting this top layer and not touching the image. The image remains unchanged. Oh, and a container can also be saved as an image. So if I go and make a new container and I install application 1 on it, and I change application 1, I can save that now as image number 2. And then I can spin up image number 2 as a new container and make another change, and so on and so forth. So how do I do all this? I have to do it with some kind of container management software. And that's where we get into talking about Docker. So what is Docker? Docker is the vessel by which container images are packaged and delivered. It's a container management tool and not an underlying technology. So it is just a tool. So Docker is like, for the Linux people, Kubernetes. And that's the, I have a lot of people telling me that that's going to be the new de facto standard. So Microsoft's going with this guy. The Kubernetes has been around for a lot longer, and it's used by larger players like Google and all their developments. So in this example, I'm talking all about Docker and how it's working. So you can use Docker to create, manage, delete, stop, and attach containers. Docker is open source. And you can run both Linux and Windows programs in Docker's containers. So does this mean that the Docker engine can extract away the OS so that it can run Windows containers on Linux?
No.
No. You can't. When you install Linux Docker on Windows, you're actually setting up a Linux VM in Hyper-V using the Linux kit. So Docker for Windows requires Microsoft Hyper-V to run. The Docker for Windows installer will enable Hyper-V for you if you don't have it. And the Linux kit is a container native toolkit that allows organizations to build their own containerized operating system. So Docker started in Linux and then was ported onto Windows so you could do all your fun container stuff. Docker storage drivers. So this is what I was talking about on the Union file system type thing. So Docker uses a series of different storage drives to manage their file systems within images and running containers. So I researched these guys briefly, but again, it got too technical too quick for me not really knowing about it. But essentially, they're Union file systems, and they have a copy on write support, which allows you to do these different layers and have everything join up and look as one continuous file system at the end. Again, there's going to be a lot of stuff in here that I don't fully understand, but I wanted to explain because as I kept researching certain parts, it took me to, well, now you have to know about this, and now you have to know about this. So I was trying to learn all I could and just throw it all in there. So now we're going to get to actually installing Windows containers on a Windows Server 2016 machine. So now that I had some base around it, it took me about 2 weeks to figure out some base technology and terminologies, and I thought, okay, I'll go ahead and install this now. It can be pretty simple. So we open up our add remove features wizard, we hit next a bunch of times, we get to our features option, we select containers, and you would say next and it would start the install, or you can use your PowerShell command. I can't see another screenshot very good, but it's install -Windows featured containers. It'll actually go and install and say you must restart finish installation. So you've installed the Windows containers, and you say finish, restart your machine, you bring it back up, and you start looking around. Where are containers? I don't know, I click start. There's nothing new in here. And I expanded all those, couldn't find it. Thought, okay, it's in Server Manager, everything's in Server Manager. No, it's not there, no Windows containers. I'm like, I'll search for containers. No, containers isn't there. And then I thought, maybe my indexing isn't working, so I'll start searching around in my file system for it. No, no Windows containers. So I'm like, well, what the hell? I installed containers, didn't I? So how do I, and this gets me back to that original question, how do I run a container? So if you gave me a container, how would I run it? This thing apparently supports containers. Well, that's when you need to have your container management system, such as Docker. So Docker comes in a couple different versions. We have our EE is the Enterprise Edition, which you'll install on Windows Server 2016. There's a CE Edition, which you would install on Windows 10. And you can also install it through PowerShell. Inside each edition, there's also a stable channel and an edge channel. So stable channels are released quarterly, so it's got their main fixes, everything's going to work. And then the edge channel is they're released once per month with any new changes, fixes, etc. in Docker. So I thought, hey, I'll do this in PowerShell because I'm supposed to be doing more things in PowerShell, and a lot of the instructions and documentation I'm seeing online were all through PowerShell. So I run this install Docker module provider, and I go and make it try to install. And the first issue I ran into is it says, hey, it has to use the NuGet provider to interact with the repositories and start downloading stuff. And on the machine I'm using, I have a VM at work, and then we have all our fancy firewalls and stuff that the networking team has on there, and it failed. So I thought, okay, well, it's probably firewall rules. So I'll try it on my machine, try it on my Windows 10 machine. I have better access to the internet. It worked, got it. So go back and I go to the firewall guy. Well, I need access to these sites. He gives me access, still doesn't work. Like, okay, well, just give me access to everything. Try again, still doesn't work. What the hell's going on here? So I'm blaming him, and he's checking. He's saying it's fine. So I go back to my machine. This is an image I made. So I've locked down a bunch of services. So I thought, maybe it's a service. So I go under my services, and I just turn, for the heck of it, I turn every single service from disabled to automatic and start one. Like even the printer service, and the telephony service, everything, just to be sure. I try to run this command again, still fails. What the heck is going on? So I deployed a brand new image from the Windows Server 2016 ISO, the exact same one I used to make my corporate image, and I ran this command and it worked. So I don't know why that happens, but I just wanted to mention in case anybody goes to install this and some of these commands don't work, it could be your customized image if you're using a customized image.
Like, I will tell my story here. Okay, like usually run as administrator will help you.
Yeah.
So like,
I always do that. Those are always run as administrator.
Yes. Okay.
Yeah.
So when you feel like I run as administrator, you succeed like that.
Yeah. So it's it was really annoying. I was bashed my head out the wall. I was like, what the heck? This is like step number 1, and I can't get it working. How is everybody else getting containers running? And I'm a smart guy. I can usually figure this kind of stuff out. So the other thing I was going to mention here is I'm using one called Docker Provider, and I kept seeing reference to another one called Docker MSFT Provider. I was like, what's the difference? What is going on here? And Dockers and all these containers are fairly new. So you start looking back and you're finding documentation from 2015 to 2017. But the information's changing. So a lot of my searches, I was very narrow and just trying to look for things updated in the last year or the last month to make sure I'm getting the most relevant information. So one of the things I did see, there are 2 different providers. Install module Docker Provider and install module Docker MS Provider. So all the Microsoft examples use this one, and all the latest stuff I'm seeing is using this one. So I was seeing a lot of different examples, and they're doing basically the same thing. So Docker Provider, so this is off the Docker repository site. It talks about the version I'm using is 0.0.3, and it was released in September 21st, 2007, updated September 22nd, 2017. It's got almost 5,000 downloads, so not a lot of downloads. It's got an owner and an author. The Microsoft Provider was released in 2016 and hasn't been upgraded since. But it has almost 200,000 downloads. So everybody's using this one. But what's the difference? There's really nothing in the documentation to say a difference one way or the other. It's just there's different owners on who own them. And I don't know what's different, but I just stuck with the first one. So it's just something to be aware of if you're looking out there to install. There are different commands, and just depending on which provider they're using. So I'm again installing this provider and not that one, and that's why you'll see all my code referenced with this guy. So now we want to install Docker so we can actually manage our containers. We do the install module Docker Provider /force, and I did verbose mode because as it was failing, I was trying to figure out why I had verbose mode to see everything. So it shows me, it tries to download everything. Good, we've got it. Next we have to install the package. So install package Docker Provider, and it goes through, does all the stuff. It says it's installed it, gives us a version, source, and now we have Docker. Now we want to test it. So how do I know this is actually working? How do I know my containers work? So they have a couple different examples you can run, and this is one of them off a lot of the sites. It's the famous Hello World. So we do Docker container run Hello World nano server, and I'll explain what all this stuff means in some slides coming up. But basically it goes out, starts trying to download it. Once it downloads it, it extracts it. Once it extracts it, it runs it and says, hello from Docker. This message shows that your installation appears to be working correctly. Great, running containers. It's awesome. Container expert now. So, to mention here quickly, so this is another example from Microsoft on how to run a .NET sample. The top one is just running it normally, so in your Windows container, but if you want to run it in a Hyper-V container, that's when you have to specify the isolation mode is Hyper-V. So, unfortunately, I was not able to get an example of this working because the way our VMware environment is set up, we don't have something turned on our ESX host that provides virtualization on top of virtualization, so I couldn't get Docker to recognize that it could install, or Windows to recognize that it could install Hyper-V on it to do these Docker containers. The Hyper-V Docker containers anyways. But didn't stop me from doing the regular one. So where do I get all these containers from? So that was another thing. I saw a couple examples on where the heck is everybody getting these from? Like, how do I know to download Microsoft Windows Server or a Debian server or whatever type of server? And that's why we have Docker Hub. So you go to Docker Hub, it's the official repository, and you can search. And when you search, there's gazillion results. There's so many different results for so many things. So I looked up some Linux ones here. So we have Ubuntu, and we have the HTTP daemon, and MySQL. You click on details, and details will show you the commands to run to install it, show you the different versions that are available for you. So there's a lot of different options there. So Docker Hub is a registry. So it's a registry where everything's stored, contains all the images. You can push or pull from this registry. So to pull, anybody can pull, you don't need any accounts. To push, you need to have an account to actually upload the data. Your Docker host, which is my Windows 2016 server, which I installed and installed Docker on, it'll have a cache, so when you do pull, it will check to see if you already have some of the bits, and will only pull what you need. So when I pulled down that first Hello World, it pulled down Nano Server. If I pull down another image that wants to run IIS on Nano Server, it's going to look and say, you have Nano Server. That was 4 gigs. I'm not downloading that. I'm only downloading, what was it, 4 gigs? It was 400 megs or something like that. Then it won't download that. It will only download the IIS layers that you need. Okay, to access the Docker host, you'll need a Docker client. Client talks to a daemon that's running on the host. The daemon will expose its APIs to the client. The client can push, pull, create, run, and commit containers on there. So it uses a syntax of Docker pull. We list the registry, which would be Microsoft. We'll list the project, which would be, there could be project level or just an image. So the registry would be Microsoft, and the image would be Nano Server, and there would be a tag as well. So Docker pull Microsoft Nano Server, and a tag is just a revision. So by default, your default tag is latest. But if you have multiple versions, it could be latest, it could be 1703, it could be 1709, and that's where you'd use that repository site to see what the different options are. And when you start creating containers and images, or images anyways, you will save them and have different tags. And I'll show that in an example in a little bit. So here's some tags from Nano Server 1709, 1709 with a hotfix installed, the latest version, and different languages. So I can actually pull Nano Server in different languages if I wanted to run a different language. And on my server when I was testing, I had the Docker image, so I had 2 Hello World images because I tried from various sources. I had the latest tag and the Nano Server tag. And for my Microsoft Nano Server, I have the latest tag on that one. When I pull a Docker image, where is it stored? And as I was writing this presentation, I was thinking all the questions I would ask myself if I was watching this presentation on, okay, so I pulled an image, where does it go? I didn't know. So I found a command called docker info, and it says, hey, your default root directory is here, which is C program data Docker. And again, this is a Windows machine, so I'm like, great. So I go into that folder, and there's nothing that says images. There's nothing that's called the standard Windows format for these things. I see this nice little subfolder called Windows Filter, and it has all these guys. It's awesome GUIDs, but they line up to when I downloaded and did all my testing. So I go into those, and they show even more obscure files, but I'm assuming that's my image. So that's where my image is stored. It's another fun thing. I totally expect it to be some kind of file called like Microsoft _Windows _, or you know how they name their ISOs. Basically expect it to be an ISO sitting there with some other custom name or .img file, whatever the case may be, but no, just stored there. Okay, so I've downloaded a container, or an image, so how do I run a container? To run a container, we have different Yeah, so hopefully I did a half decent job explaining it, or at least got you guys interested enough to do some more research on it or trying to do something.
So is the Docker management free? Comes
Yeah.
with Windows?
No,
You can-
doesn't come with Windows.
You can download it, but you don't have to pay licensing.
Nope, you don't have to pay anything.
It's working on Windows Server 2016 and Windows 10 or 2012 as well.
Nope, not on 2012, 2016 and 10.
What was that, 2016 and what?
And Windows 10. Yeah. Yeah, so a lot of people start with Windows 10 and do all their development and testing to see that it'll work, and then that's when they hand their container off and you put it on your, Windows features, Windows 10 installed. Yeah, Paul?
So, I have a server 2003 instance and I have some legacy app on it.
Yeah, we scan it. And I just it was regular black. See, that's how I got my Microsoft job. Yeah, no, then that's the thing I kept asking people too. And really, you need to have your original source code. You need to get it working in a container. So you don't necessarily need to worry that it's on Windows 20, or on Windows 2003. You need to worry that the technology will work on something like in a .NET framework, or you can convert it to PHP or something like that if it's a type of website. So that's the thing that was driving me nuts, because they pitched it as magical software, scan it, containerize it, it's in the cloud. No, it's rebuilt. So anything new, it's going to be amazing. So you build everything new, and you make it so it'll work in container. You can deploy it as needed. It can scale. It can do everything. But taking legacy stuff is not as easy as they're making it sound. Because my issue is, again, I have all this old software that does not, we don't have installation software. It's just running on this old server. I don't know how it works. It's there. There's some configs. Is it using some customized changes or COM DLLs or anything? I don't know. So how do I get that in the cloud? The other thing I was told too is Docker or containers are not the best solution for anything that requires GUI. So if you have some kind of application that has a GUI, it's not going to work well. Though I did hear that Oracle's making a big push to put a bunch of their stuff in containers, and some of those things would have GUI unless they've talked about switching everything over to web applications that are going to use like the stateful web applications through the parallel mode where they connect through all their containers are connected. So yeah, but if you were developing a new .NET application, then you want to make it so it's going to be containerized and you can just throw it up there. Yeah.
Sure, but then your real answer is use just a virtual machine, like you convert your server 2003 to some virtual machine.
Yeah, to a virtual P2V it and then run it there for a while. There's probably going to be a solution if there isn't already, and I haven't, again, fairly new to this, haven't seen that solution, but I know that's what I'd like to do, is to take some of these existing old apps that don't need a dedicated server or VM. Like literally some of these things are, a couple HTML pages that are running on an old IIS server, but nobody has time to move it. We just want to convert it. Okay, go ahead, Bob.
And another question. So I'm still a little confused as to updating and patching these sorts of things. I guess, is the assumption here that no important data will live in your images? Like, is this the servers as cattle metaphor?
Yeah. Yeah.
Like, you assume that all of the data you care about is someplace else, because you can't, so if you've got some writable layer, you can't just get rid of that, right?
Well, it's writable in the container, so
Right.
I guess the idea is that when you deploy your website, it's coming from an image, it's making containers, so it has that writable layer, and maybe it's saving some logs locally or something like that, but you're not storing data on there because you won't have a way to easily get it off. It's just...
Yeah, but then I need to do an update, right? So now IIS has an update, the IIS layer is changed,
Yeah,
and now I need to
redeploy. You have to make sure your application's going to actually run on that change and redeploy.
but then there's downtime. If there was data on my writable layer, then I'm supposed to have to take it down.
Yeah, but they're supposed to be
and
the
redo it.
stateless ones. So if you're using that web server example, you would just deploy a new web server with your new stuff and point people at it and tear down your old one.
So it sounds like, from what you're saying, Paul, when you're patching your you were talking about this before, when you're patching your IIS server, it's actually creating a brand new container. That old IIS server is still in existence, so your old containers are still running on that old IIS server, a second new IIS server container is being created, and now you have to point your upper levels to that new IIS image in order to redeploy it onto that new IIS up patch.
Yes, okay, so like, can I answer that?
Yeah, definitely.
Okay, so there is something called Docker volumes. Okay, so Docker data management. Okay, so your data has been abstracted from your regular OS, and Docker volumes have been maintained, and these can be mapped to multiple containers or single container, the way that you want. So as you rightly said, when a new version you want it, okay, so there's a blueprint deployment, so new version will take the same content, you're going to map it to the same content, and as long as you want to say 50-50%, and when you like the new application, you're going to carry it over to the old one, kill it. So that's how we do that, and most of the real time of the production, okay, Pokemon is completely on Docker, okay. If you like the complete scalability or how the Pokemon application is from Docker containers running on the Google Cloud. So it is production ready. It is nowhere like a playground anymore. So production ready, and it is scalability of it. But as I said, okay, ecosystem and the knowledge that has to go on the administrators is not there.
Yeah, and that was the main point of this, was just getting some more awareness around it, because developers seem to know all about it and they have the edge, but then when it comes to us, again, they give you a container and say, make this work for me. Well, how? So I started asking the questions and started looking into it. So, well, thank you everybody for attending tonight. Sorry it's a little short. It was, again, a lot for me to take in and try to figure out and present there. But, so next month, I'm looking at doing that Cloud Ready presentation that I didn't get to in June. So we had that emergency cancellation there. At the same time, Mike will be looking at talking about, he'll be doing the second topic, and that's just to be determined, so there'll be 2 topics there. And for our January event, which would be on, so our next one is Monday, November 27th, and that's when I'd be looking to do Are You Cloud Ready? So just talk about steps that are needed to move to the cloud if you're not already there, so specifically moving to Azure or getting ready so you get your environment prepared. And then on Monday, we don't do anything in December, but in January, Monday, January 29th, at my company we've recently implemented Jira, and we've implemented the on-premise version of Jira. So we're going to go through how I did the installation and setup, so I'll do the infrastructure point of view, things and challenges I ran into, and then I'll have my business development analyst, he'll talk about all the different customizations and how to make it workable and usable. So I'll show some demos and some slides about this is the setup, these are some things we needed, and then he'll talk about these things he tweaked, and he set up these different menus to allow for this, or we set up this for RFCs, we set up that. So we're in conjunction on that one, and it was pretty neat. It was kind of a pain, so Jira's that open source one. I specifically geared our quoting process to go and get to favor ServiceNow, but then he retooled it to get Jira because his manager said Jira was cheaper. It's like $10 a license for administrators versus ServiceNow's being multiple thousands plus training. Though ServiceNow, I think, is a little better solution since it's all cloud. Jira does offer a cloud solution, but it's not the same. So when I think cloud, I think, and I just tell my other presentation, I think geo-replicated around the world cloud service. Whereas some people think cloud as it's not in my location. So if Martin's running a bunch of servers in his basement, he can call himself a cloud hosting facility if he wanted to. So this Jira cloud service to me is kind of like that. Somebody's running it at their company, maybe slightly better than the basement, but still don't trust it. Anyway, so that'll be the January presentation, and then still looking for presentations going into February, March, April, and June. We have Paul here from the Linux user group. Paul, what do you guys have coming up?
So this is going to be a presentation by a guy who works at the University of Waterloo. They've done some distributed replicated file systems with versioning that's in 3 different buildings, and it's built on Nextcloud, which is the replacement to OwnCloud. And so they've got that working, and he's going to be talking about how that was set up and how it works. And so that's next Monday at 7 p.m. down at St. John's Kitchen at Victoria and Weaver.
Great. And Thomas here from VMUG. Thomas, what do you guys have going on?
Yeah, so we run VMware user group in the area. We have 3 or 4 meetings every year, And if you work with VMware or you want to learn about VMware, I encourage you to come to those meetings. It's free of charge. Basically, you just sign up at the vmug.com website. You become a member and you will be notified every time that we have a new event.
Sorry, what was that? VMUG?
VMUG. So VMware User Group, and the acronym is VMUG. VMUG.com.
All right, that's great. So thank you everybody for attending, and hopefully see you next time. Oh yeah.